Alright, I'm back with another tutorial video here. In this tutorial video, I'm going to demonstrate how to configure a GRE tunnel. Here is the network diagram that I'll be using for this demo. Router 1 and router 2 is going to be in one geographic location, and then router 4 and router 5 is in another geographic location. Router 3 is going to represent the internet. So basically router 2 is going to have its default gateway pointing to its ISP, and the router 4 is going to have its default gateway pointing to its ISP as well. So the GRE tunnel is going to be formed between router 2 and router 4. And let's go ahead and take a look at the IP addressing that I'll be assigning for the GRE tunnel. For router 2, the source of the tunnel IP is going to be the IP address of gig0/0, and then the destination IP is going to be the IP address of routers 4's gig0/0, which is 64.124.34.4. So that is going to be the source and destination for router 2, and then for router 4, source and destination is going to be flipped. For example, the source IP is going to be router 4's gig00's IP interface, and then for the destination, IP address is going to be router 2's gig00, which is 64.124.23.2. And then for the tunnel interface IP, it's going to be a /30 address. I'm assigning that as 10.1.24.1 for R2, and then the tunnel interface IP is going to be 10.1.24.2/30 for router 4. And I already have my IP addresses pre-configured, so let's go ahead and take a look at that here. Let's first take a look at that for router 1. As you can see here, router 1, the loopback is already configured here, and then gig0/1 is 192.168.12.1, and then also the and then that's pretty much it for router 1. Router 2 has its gig0/1 connecting to R1 with that IP address, the loopback there, and then the WAN interface is the 64.124.23.2, and I have a default route pointing to 64.124.23.3, which is pointing to my default gateway, my ISP, for example. Alright, so that's router 2. And then router 3 is just pretty much simply configured to have the IP addresses on the interfaces connected to R2 and then R4. Nothing too fancy there. For router 4, we can take a look here. That the loopback is 4.4.4.4, and the gig00, which is my WAN interface, is going to be 64.124.34.4, and the inside interface is going to be 45.4, 10.10.45.4, which connects to router 5. And I do have a default route pointing to my ISP, which is 64.124.34.3. And that's that. And let's take a look at router 5. For router 5, 10.10.45.5 for gig0/1, and just a loopback address. Okay, so let's go ahead and configure the GRE tunnel between router 2 and router 4. I'll start with router 2. Config T, INT, I'm going to give it a tunnel 0 interface. Tunnel source is going to be gig 00 interface here, which is 64.124.23.2, and that's it. And then tunnel destination is going to be 64.124.34.4, which is router 4's IP address on gig 00. Okay, that's the tunnel source and tunnel destination. Now I go into the IP address itself. IP address, I'm going to give my tunnel an IP address of 10.1.24.1, 10.1.24.1, 255.255.252. Alright, so that's R2's tunnel configuration. Let's go into R4. Here's R4 right here. So this is what I want to do with R4. Config T, INT, T0, tunnel source is going to be 64.124.34.4. Tunnel destinations the other side, 64. I'm gonna form a tunnel right here, so it's gonna be 64.124.23.2. All right, and then I need to give it an IP address. IP address 10.1.24.2, 255.255.255.252. All right, and that should be good. And let's see if I can ping from R4 to R2. Ping 10.1.24.1. And there it is. I'm able to ping across from R4 to R2. Let's go ahead and take a look here. Show interface T0. Tunnel's up. It looks good. All right, so we got that there. Let's go ahead and so what we can do next is go ahead and add loopback 0. Actually, the next thing we could do is, let's see, ping 10.1.24.2 is that side. That's good. Let's go ahead and add router 1. Let's add router 1's all the interfaces for router 1 into OSPF. And then we're going to do the same for router 2, but we're only going to add the 192.168.12 and the 2.2.2 into OSPF, okay? Because what we want to do is we want to ping from R1 all the way across to R5. So we're going to add this into OSPF, and then likewise I'm going to add R4 and R5 into OSPF, but I'm not going to add the WAN IP address into OSPF because that'll cause recursive routing, so we don't want to do that. So let's go ahead and do R1. Config T, router, show IP OSPF, nothing big T, INT, LO 0, IP, OSPF 1, area 0. Okay. OSPF 1. All right, and then the same for gig 0/1. All right, so loopback 0 and gig 0/1 is added into OSPF. Let's do the same for router 2. I'm going to add the loopback, and then I'm going to add gig 0/1 into OSPF. Now the loopback. Okay, so loopback 0 and gig 0/1 is now into the OSPF. Show OSPF. Okay. There we go. Neighbor has been formed between R1 and R2, and we can see that here. All right, let's do the same for R4 and R5. For R5, I'm going to add all the interfaces into area 0, and I'll do that by the by another command. Router OSPF1 network 0.0.0.0 area 0. Done. Show IP OSPF INT brief. There we go. Loopback 0 and gig 0/1 is added into OSPF. Let's do the same for router 4, just adding the loopback 0 and then the gig 0/1 interface IP. Let's go ahead and go into router 4 here. Okay, loopback 0 and gig 0/1 is added into OSPF, just waiting for the neighborship between router 4 and router 5 to come up. Show IP OSPF neighbor. Almost there. Oh, there it is. All right, it's up. All right, we got neighbor between R4 and R5. So from R5, can we ping to router 1.1.1.1, ping 1.1.1.1, and what we can do is we can just say ping 1.1.1.1, and we should be able to get there. Let's see, do I have my routes in place here? Show run, R4. Dun, 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 dun. 2, and I'm not learning. Okay, so what I need to do is now add the tunnel 0 into OSPF. Forgot to do that, so we need to add tunnel 0 into OSPF for all the routes to show up. So let me do that. T0 IP OSPF1 area 0, and then the same for router 4. You need to add tunnel interface 0. Config T INT tunnel 0 IP OSPF1 area 0. All right. So let's wait for that to come up, and there it is. It's showing neighbor from R4 to R2 has been formed, and we should see all the routes now from R5. Let's take a look at it again. All right, we're seeing more routes. Show IP route OSPF. There it is. Ping 1.1.1.1. All right, I can ping 1.1.1 from R5, ping it all the way across, and I'm seeing all my routes here. I'm showing the 10.0 route, the 192.168 route. All right, let's take a look at R1 real quick. Show IP route OSPF. I'm learning 2.2.2. I'm learning 4.4.4. I'm learning all the loopbacks. 10.1.24. 10.1.24. That's the tunnel interface. I'm learning that as well. Through router 2. All right, so that looks good. So let's see here. So let's play around with MTU settings. So if I look at tunnel router 2, show INT T0. Let's see here. MTU is 1476. Not 17,916. It's actually 1476 right here. And let's go ahead and do a ping from R1 to R5. Ping 5.5.5.5. Size 1500. 16, let's say 2000. Okay, it's going all the way across. But if I set the MTU on router 2, INT-T0, INT-T0, IP MTU, I can set limits on this. If I set it to 1500 and I don't do the DF setting, I'm still able to ping. I'm still able to ping. Now, what I should have done is add a DF bit. Don't fragment. I'm telling you, do not fragment. So when I do that, oops, let's see. Config T, INT T0, INT T0, IP MTU 1500. And if I do a ping, 5.5.5.5, and I'll go across with a size of 1501 DF bit. If I do a ping with a do not fragment bit, it won't go across. But if I do a regular ping with not setting the defragment, it pings. So that's because I've set my MTU size to 1500. Okay, so that looks pretty good. Show IP route. I got all my routes in place and everything looks good there. So I set the MTU size on R2. How does that affect pinging from R5 to R1? It's the same thing. So if I go ping 1.1.1.1 size 1501, it should ping. It should be able to ping across because I'm not setting the defragment, do not fragment bit here. All right, and if I do the DF bit here, then it won't. So taking a look at router 2, show INT T0. So we know that the MTU maximum size is 1476. So fig T INT T0, no IP MTU 1500. Right? Is that what I said? Show run INT T0. Okay, so we're not setting the MTU to 1500. We're actually setting the default MTU of 1476. Actually, let's go ahead and configure IP MTU 1501. Show INTT0. Let's remove that. So with 1476 by default, if I ping from R5 to R1, 1476, even with a do not fragment, I'm still able to ping it because I have not exceeded the MTU size of tunnel 0. Now, however, if I ping 77, size 1477 with a DF bit set, I should not be able to ping. There it is, right? Because I've exceeded the default of 1476. All right, so basically that's how you configure the GRE tunnel. Again, let's take a look at our tunnel configuration. You need a tunnel source IP, tunnel destination IP, and then you need to assign the tunnel IP address. Same for router 4. And to get all the OSPF routes in there, be sure to add tunnel 0 into your OSPF statement. All right, so that's how you configure GRE tunnel with OSPF included.